Welcome to Pratham Science Academy classes, and we are about to start set subset one of set number four for the year 2024 of Mathematics Standard. And to begin with section A, this section comprises of MCQs of 1 marks each, and we are about to start the question number one. It's given that AX it's given AX plus BY is equal to a square minus b square and bx plus ay is equal to 0. We have to find the value of x plus y. Okay, so let's say this is the first set of equation and this is the second set of equation, and I'm going to multiply the first set of equation with b and the second set of equation with a, which gives me abx plus b square y is equal to b into a square minus b square. And if I multiply this with a, so this is abx plus a square y is equal to 0. And this is, I'm going to subtract this, so this is gets cancelled. And here y is common, so it's b square minus a square. And this is b into a square minus b square. If I take negative out here, so this is b square minus a square, this gets cancelled, and y is equal to negative b. So y is equal to negative b, and this equation gives me, I can get x from here, so x plus b into negative 1 is equal to a square minus b square. So this is, sorry, y is negative b, so this is negative b, so this is negative b square is equal to a square minus b square, this gets cancelled. Ax is equal to a square and x is equal to a square by a, which gives me x is equal to a. So x is equal to a, and we have to find the value of x plus y. So this is a minus b. So x plus y is equal to, the value of x is a and value of b is negative b. So x plus y is equal to negative b. That is C is the correct answer. Okay, moving on to question number two, which says that the HCF of two numbers is 65. Sorry, HCF of two numbers. So these are the two numbers. So HCF of the numbers 65 and 104 is 13. And LCM of these two numbers, that is 65 and 104, is 40x. We have to find the value of x. So for two numbers, we know that HCF into LCM is always equal to product of two numbers, and HCF is 13, LCM is 40x, product of two numbers. So product of two numbers are 65 into 104, which gives me x is equal to 65 into 104 divided by 13 into 40. So 35 are is 65, 5 8 are is 48, 1s are 8, and 8 3 are is 24. So x is equal to 13. That means B is the correct option. Let's move on to the next question, that is question number three. Okay, for question number three, it's given that a polynomial p of x. So this is 3, and p of x is given as x squared minus 5x plus 6. And we have to find the value of p of 1 plus p of 4. So the value, let's find out the value of p of 1. And for that, we have to replace x as 1. So this is 1 square minus 5 into 1 plus 6, which is equal to 1 minus 5 plus 6. Negative 4 plus 6 is 2. And p of 4 is 4 square minus 5 into 4 plus 6 is 16 minus 20 plus 6, which is also 2. And if we add them, so 2 plus 2 is equal to 4. So B is the correct option for question number 3. Okay, moving on to question number 4. And question number 4, it's given the discriminant of the quadratic equation is 16. So this is question number 4, and the given quadratic equation is 3x squared minus 2x plus c is equal to 0. And it's given that d is 16, and we know that discriminant is given by b square minus 4 into a into c. B is negative 2, so this is negative 2 square minus 4 into A is 3. This is A coefficient of x square. C is C, so this is 4 minus 12C is equal to 16, and minus 12C is equal to 12, which gives us C is equal to negative 1. So C negative 1 is the correct answer for question number 4. Moving on to question number 5, if an arc subtends an angle of 90 degree at the center of a circle, so let's say this be the circle, and an arc is subtending an angle of 90 degree at the center, so this is 90 degree at the center of a circle, then the ratio of its length to the circumference of the circle. So the length of, that is arc length, is given by, so we have to find the ratio of the length to the circumference. And we know that the arc length is given by theta by 360 into 2 pi r, and the circumference is 2 pi r. So this gets cancelled, and theta is 90. So 90 by 360 is 1 by 4, which is equal to 1 is to 4. So 1 is to 4, that is B is the correct answer. Option B is the correct answer. Okay, let's move on to question number 6. Okay, for question number 6, it's given that the area of area of the sector of a circle of radius 12 centimeter is 60 pi centimeter square. So let's say this is the circle and this is the sector with area 60 pi centimeter square. We have to find the central angle, that is theta. Now it's given that area of the sector is 60 pi, and area of the sector is given by theta by 360 into pi r square, which is equal to 60 pi. Pi and pi gets cancelled. Theta we have to find out, so radius is 12. So this is theta by 360 into 12 square is equal to 60. Let's find out theta, which is equal to 60 into 360 upon 12 into 12. So 12 5s are 60, it's 30, and the central angle is 150 degree. So 150 degree means option D is the correct answer for the question number 6. Moving on to question number 7. Okay, for question number 7, it's given that the difference of mode and median of a data is 24. So it's given that mode and minus median is equal to 24. Let us see first set of equation, and we know the empirical formula for mode, median, and mean. So I can write this. We know the empirical formula is mode is equal to 3 median minus. So we know that this mode is equal to 3 median minus 2 mean. So let me just take this to the left hand side. So mode minus 3 median is equal to negative of 2 mean. Let this be second equation. And if I add this first and the second equation, or let me just subtract these first and the second equation, I'm going to remove this. So we are doing question number 7. And Okay, these are the two equations, and I'm going to subtract these two. So this gets cancelled. Minus median plus 3 median is now 2 median, and this 24 plus 2 is 24 plus 2 mean. Now we have to find the difference of median and mean. So I'm going to take this to the left hand side. So 2 median minus 2 mean is equal to 24. 2 is common. So 2 median minus mean is equal to 24. This is 12. So median difference of median and mean is 12. So the correct option is option A, that is 12. Okay, now moving on to question number 8. The two dice are tossed simultaneously, and we have to find the probability of getting odd numbers on both the dice. So when two dice are thrown simultaneously, so total outcomes is equal to 6 square, which is equal to 36. Now, if two dice are tossed simultaneously, the probability of getting odd numbers. So we know that the odd numbers are 1, 3, and 5. So let's get the combination of these for the odd. So the first odd will be the doublets. 3, 1, 1, 3, 3, 5, 5, 5. And next one would be the combination of 1 and 3. So 1, 3, and 3, 1. Next one is 3, 5, or 5, 3, 5, 3, or 3, 5. And next is 1, 5. So this is 1, 5, and 5. So we have total of 3, 2, 5, 5, 2, 7, and 2, 9. So these total outcomes are 9. So the probability would be, the required probability here would be, so our favorable outcomes are 9 and the total are 36. So it's 9 by 36, and which is 1 by 4. But out of these options, it's the option D, so 9 by 36. Okay, now next one is to find the ratio of the total surface area of a solid hemisphere to the square of its radius. This is question number 9. And we know that hemisphere total surface area is the curved surface area plus, so this area is 2 pi r squared, this area is pi r squared. So hemisphere's total surface area will be 2 pi r plus pi r squared, which is 3 pi r squared, and we have to divide this with the square of the radius. The square of the radius is r squared, so this is equal to 3 pi by 1, and the required ratio should be 3 pi is to 1. So 3 pi is to 1. Option C is the correct answer. Let's move on to question number 10. Okay, for question number 10, it's given that sine theta is equal to 1, and we have to find the value of half sine theta by 2. So let's find out theta first. So sine theta is equal to 1, and we know that the angle for which sine theta is 1 is sine 90. So I replace 1 with sine 90, which gives me theta is equal to 90 degree. So now half into sine theta by 2, which is 90 by 2, this is 45. And sine 45 is 1 by root 2. So our answer is 1 by 2 root 2, which is option A. Okay, moving on to question number 11. So two lines are given to be parallel. The equation of one of these lines. So one of the line is 3x minus 5 is equal to 2. And if the lines has to be parallel, what should be the equation of the second line? And if we know that for parallel lines, so parallel for parallel lines, a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. and this is minus 15x plus 9y is equal to 5. Okay, because here a1 by a2. So if I a1 by a2 is minus 1 by 3, b1 by b2 is also 1 by 3, and c1 by c2 is 2 by 5. So these are not equal to 2 by 5. So our option is option D. You can check for all these one by one. Okay, and for the 12th question, three numbers are in AP. We have to find what is its middle term. So in an AP, there are only three numbers and whose sum is 30. So let these numbers be A minus D. Whenever the sum of the numbers is given, we have to take the terms as A minus D, A and A plus D, where A is the middle term. So it's given that A minus, so let the numbers in AP base. Now there's sum is 30, so A minus D plus A plus D is equal to 30. Now D and D gets cancelled. A is 3, A is equal to 30, which gives us A is equal to 10, which is the middle term. So middle term is 10. Okay. Now moving on to question number 13. It's given that in triangle ABCDE is parallel to BC. So that means angle D is equal to angle B, and DE is parallel to BC. Similarly, angle E is equal to angle C. So angle E is equal to angle C. And the reason being these are the corresponding angles, and we know that the corresponding angles are equal. So that means triangle ADE is similar to triangle ABC. And if these triangles are similar by a rule, so that means AD by AB. So AD by AB should be equal to A by AC. Let's put in the values. AD is 4, so this is 4. AB is 9. AE is not known. EC actually should be AD by AB, and AE by AC. This should be AC. This is actually AC. So AE by AC, and AC is 13.5, which gives us the value of E. If we cross multiply this, this is 4 into 13.5 by 9, and 9 1 is 9.5, which gives us 6 centimeters. So AE is 6 centimeter, and AC is 13.5, which gives us EC is equal to AC minus AE, and 13.5 minus 6 is equal to 7.5 centimeters. 7.5 centimeters, that is B, is the correct option. Okay, moving on to the next question. That is question number 14. At some point, some time of a day, it's given that the length of the shadow of a tower is equal to its height. So let's say this is a tower. So it AB be its height and BC be its length of the shadow, and let this be angle theta. So it's given that, so angle theta would be AB by BC, and it's given that the height is equal to the length of the shadow, that is AB is equal to BC. So that means tan theta, I can write it as AB by AB, which gives me 1. And we know that the angle for which the tan is 1 is tan 45. So instead of 1, I've written tan 45, which gives me theta is equal to 45. So theta is equal to 45, that is B is the correct option. Let's move on to question number 15. For next question, that is question number 15. It's given that AB and AC are tangents to the circle from the external point A, and we know that tangents drawn from an external point to a circle are equal. So these are tangents drawn from external point to a circle, and these are equal. So AB is equal to AC, and angle opposite to AB is C, and to AC is B. So that means angle B should be equal to angle C, and this being 42 degree. Reason being, angles opposite to equal sides are equal. So these are angles opposite to equal sides are equal. Now we can use the angle sum property, that is angle A plus B plus angle C is equal to 180 degree, and this is because of angle sum property of a triangle that says that sum of measures of all the angles of a triangle is 180 degree. Now angle B and C are 42 degree each, which gives me angle A is equal to 180 minus 84, and this is equal to 96 degrees. So 96, that is A is the correct option in this case. Moving on to the next one. Okay, for next question, that is question number 16. This was 15, and this is question number 16. We have to find the fourth vertex D of a parallelogram ABCD whose three vertices are. Okay, let's suppose this is a parallelogram ABCD, and we all know that for a parallelogram, diagonals bisect each other, and let these be the diagonals AC and BD. And I'm going to write down the coordinates. For A, it's minus 2 comma 3, and for B, it's 6 comma 7, and for C, it's 8 comma 3, and for D, we have to find the coordinates. Okay, diagonals of a parallelogram bisect each other. That means O is the midpoint of AC, and O is also the midpoint of BD. So I'm going to use the property of the triangle, which says that diagonals of a parallelogram, they bisect each other. That means the coordinates of midpoint of AC should be equal to coordinates of midpoint of BD. And how do we find the coordinates of midpoint of AC? That is x1 plus x2. So this is, we use the formula x1 plus x2 by 2, y1 plus y2 by 2. And here we are also going to use the formula x1 plus x2 by 2 and y1 plus y2 by 2 in both the cases. Okay, x1 plus x2, this is x1 and this is x2. So minus 2 plus 8 is 6. And let me just write it down. Minus 2 plus 8 divided by 2. And this is y1 and y2. So 3 plus 3 divided by 2. This is 3 plus 3 divided by 2. And in this case, x1 is x, so x plus 6 divided by 2, and y plus 7, y plus 7 divided by 2. So minus 2 plus 8 is 6, so this is 3 comma 3, and x plus 6 by 2, y plus 7 by 2. Okay, if I equate the x and the y coordinates, so x is equal to 0, and 3 is equal to y plus 7 by 2, so y plus 7 is equal to 6, y is equal to negative 1, and the fourth vertex has the coordinates 0 comma minus 1. So 0 comma minus 1, that is B is the correct option here. Okay, moving on to question number 17. And for question number 17, it's given that the probability of an event and not E, that is probability of E and not E is given as Q. We have to find the value of Q square minus 4. So probability of E plus probability of not E is Q. And we know that probability of an even and probability of not is equal to 1. And if you compare these two equations, with this gives me Q is equal to 1. So if Q is equal to 1, we can easily find the value of Q square minus 4. So this is 1 square minus 4, which is negative 3. So A is the correct option here. And moving on to question number 18. Okay, for question number 18, QR is the common tangent and to the two circles touching externally at A, the tangent at A meets QR if AP is equal to 4.2. So this is AP, which is 4.2 centimeter. Now AP and QP are the tangents drawn from the external point P, and we know that tangents drawn from external point to a circle are equal. So this is 4.2. This is 4.2. These two are also the tangents drawn to this circle. So this is also 4.2. And 4.2 plus 4.2 gives us the value of QR. So this is 8.4. So C is the correct option. Let's move on to question number 19. Okay, for question number 19 and 20, which are assertion and reason based questions. Two statements are given. One is labeled as assertion and the other is labeled as reason. We have to select the correct answer to these questions from the codes A, B, C, and D, and these are the codes. So starting with question number 19, assertion says that midpoint of a line segment divides the line segment in the ratio is 1 is to 1. That is correct. Because if a line segment is divided, let's say this is a line segment and it joining the points A and B and B is the midpoint, then it's divided in the ratio 1 is to 1, which is correct. Now the ratio in which the point minus 3 comma k divides the line segment joining the comma is minus 5 comma 4 and minus 2 comma 3 is 1 by 2. This is not the correct reason for this because the correct reason for this would be the section formula. So using the section formula, we can find out the ratio uh, for which the midpoint of a line segment divides the line segment. So this is not the correct reason. Assertion A is true, but reason R is false. So assertion A is true and reason R, assertion A is true, but reason R is false. And so we have to select out of these assertion A is true and reason R is false. So C is the correct answer for this. So C is the correct answer. And moving on to question number 20, which is also assertion and the reason based. It says that if the circumference of if the circumference of a circle is 176 centimeter, then its radius is 28. Let's try to find out. And we know that circumference is given is 176 centimeter. Circumference formula is 2 pi r. So which is 176 and we have to find the radius. So this 176 into 1 by 2 into 7 by 22, 11 2s are and 66 to its 11 2s are is 22 and so this is 11 ones are 11 and 6 are 11 ones are 11 and 11 6 are is 66 and once again it's 2 it's 4 and the radius is 28 centimeters, so that means this is true. Circumference is equal to 2 pi r is the reason correct because we have used this formula to find out the radius, so it's also true. So that means both assertion and reason are true and reason R is the correct explanation of assertion A. So option A is the correct answer for this one. Okay, let's move on to section B. And this section comprises of very short answer questions of 2 marks each. So moving on to the first question. of section B. So it says that there are three bell tolls at intervals 9, 12, and 15 minutes. If they start tolling together, after what time they will toll next toll together. So that means we have to find out the next time, that is after what would be the minimum time that these three tolls will toll together once again. So we have to find the minimum possible times, and for the minimum possible time, we have to find the LCM. So let's find out the LCM. So 9 is equal to 3 square, and 12 is equal to 4 into 3. So it's 2 square into 3. 15 is equal to 3 into 5. And let's find out the LCM. So LCM for these three, it's 3 square, and it's 2 square into 5. The 3 square is 9 into 4 into 5. So this is 36 into 5, which gives me 6 5s are 30, 5 3s are 15, and 180 minutes. So after 180 minutes, these bells toll together again. And now, next we have to find out for question number 22. Uh, it's given that the minute hand of a clock is 14 centimeter long. We have to find the area on the face of the clock described by the minute hand in 15 minutes. So this is question number 22, part A. Now the minute hand of a clock is, let's say this is the clock with, okay, this is the clock. I'm going to put on the numbers. Okay, now the minute hand of a clock is 14 centimeter long. Find the area on the face of a clock described with the minute hand in 5 minutes. So let's say this is the minute hand, and for every 5 minutes, so if I, for every 5 minutes here, there will be a total of 12 sectors. Okay. And for every, so this is the minute hand, let's say it goes from 12 to 1. So this is the angle set by the minute hand in 5 minutes, let's say, which is theta. So this complete angle is 360. So theta is equal to 360, and we have a total of 12 sectors. So divided by 12, which gives me 30 degrees. So its theta is equal to 30 degree. And now this is the angle swept by the minute hand in 5 minutes. And we have to find the area swept by minute hand in 5 minutes. So area swept by this minute hand of length 14 centimeter in 5 minutes would be the area of the sector. So this is equal to theta by 360 into pi r square, and theta is 30 by 360. This is 22 by 7, and radius is, this is 14 into 14. So this is 12, 7 2 is 14, 2 6, 3, and 11. So area swept is equal to 154 by 3 centimeter square. So 154 by 3 centimeter is the area swept by the minute hand in 5 minutes. And let's also try to solve the OR part of this, which says that, okay, so we are going to solve this. Find the length of the arc of a circle which subtends an angle of 60 degree. Okay. This is 60 degree, this is O, and let's say this be the arc. And we have to find the length of this arc, and arc length is given by theta by 360 into 2 pi r. So theta is 60, it's 60 into 360 by 2 into pi is 22 by 7, and radius is 42. So this is 6, 2 3 are 6, 1 and 4, 7 2 are is 14, and we have the length of the arc is equal to 44 centimeter is the length of the arc. Okay, moving on to question number 23rd. Okay, for question number 23rd, part A, we have to evaluate this 5 cos squared. So this is 5 into cos 60 is half. So this is half squared plus 4. Secant 30 is 2 by root 3 the whole square. So this is 2 by root 3 the whole square minus tan square is minus 1. Sine 30 is half square plus sine 60 is root 3 by 2 the whole square. So this is equal to 5 into 1 by 4 plus 4 into 2 square is 4 root 3 square is 3 minus 1 upon this is 1 by 4 plus 3 by 4. So this is equal to 5 by 4 plus 16 by 3 minus 1. And this is 1 plus 3 by 4. If we take LCM here, this is 12. This is 45 plus 3, 4, 64 minus 12 upon 4 by 4, which is 1. Okay, 45 plus 64 is 12, 4. This is, sorry, this should be 15. Okay, this is 79 minus 12 by 12, which gives me 67 by 12. So 67 by 12 is the evaluation of this. Okay, moving on to its whole part, that is part B. Okay, for part B, this one, it's given that sine of A minus B is equal to half, and cos of A plus B is equal to half. For first one, we know that the angle for which the value of sine is half is sine 30. So that means A minus B is equal to 30 degree. This is equation 1. And cos of A plus B is half. And the angle. And the angle for which the value of cos is half is cos 60 degree. So A plus B is equal to 60 degree. This is equation 2. So let's try to solve these two equations. This is A minus B is equal to 30 degree, and A plus B is equal to 60 degree. Okay, if we add these two equations, this is 2A is equal to 90 and A is equal to 45 degree. And if we subtract these two equations, that should give me the value of B. So A minus B is equal to 30 and A plus B is equal to 60. If we subtract these two equations, so this gets cancelled, it's minus 2B is equal to minus 30 and B is equal to 15 degree. So this gives me B is equal to 15 degree. So A is equal to 45 and B is equal to 15. Moving on to question number 24. For question number 24, It's given that in the given figure, O is the center of the circle and angle AOB is equal to 145 degree, then we have to find the value of X. So this is the figure. Now, if we join A to any point on the circle, that is the remaining part of the circle, let this be point P. Now, angle AOB is the angle subtended by the arc AB at the center, and say the same arc subtends the angle APB at the remaining part of the circle, and we know that angle subtended by an arc at the center is double the angle subtended by the arc at the remaining part of the circle. So here angle AOB is 145 degree, which gives me angle APB. So now angle APB is half of 145 degree, which is 72.5 degree. Now APBC is a cyclic quadrilateral, so the reason for this was uh, this is the theorem in class 9, that angle subtended by an arc at center is double the angle subtended by arc on the remaining part of the circle. So this is 72.5 degree. Now ABCBC is a cyclic quadrilateral, so that means angle APB, this is angle APB plus angle ACB is equal to 180 degree, because these are opposite angles of a cyclic quadrilateral are supplementary. So these are opposite angles of a cyclic quadrilateral are supplementary. Now angle AB is 72, so that means angle ACB is equal to 180 minus 72.5 degree, and 180 minus 72.5 degree will give me 5.5, 10 minus 2, okay, it's 7, and it's 0 and 1, so 107.5 degree is the required angle. Okay, moving on to next question, that is question number 25. For question number 25, in the given figure, these two triangles are similar. And if we know that if the triangles are similar, then their corresponding sides are in the same proportion. So the R symbolic form is triangle ABC similar to triangle AHK. So that means AK is in proportion with AC. So I can write AK is in proportion with AC and HK is in proportion with BC. So HK is in proportion with BC. We know the value of AK, it's 8. AC, value of AC, we have to find out. HK is 6.4 and BC is 3.2. So this gives me 2, and AC is equal to 4 centimeters. So AC is equal to 4 centimeter. Moving on to section C, and this section comprises of short answer type questions of 3 marks each. Then we have to prove the first identity, which is we have to prove that sine theta minus cos theta plus 1. So let's write down the LHS. This is sine theta minus cos theta plus 1 upon, this is sine theta plus cos theta plus 1. Okay, because on the right hand side we have secant and theta, so we'll convert all these in the secant and theta. And how do we do that? So we are going to divide numerator and denominator by cos theta. So if I divide each and every term of the numerator and the denominator by cos theta, so this is sine theta by cos theta minus cos theta upon cos theta plus 1 by cos theta divided by, once again, it's sine theta by cos theta plus cos theta by cos theta plus 1 by cos theta. Now this is 1. Sine by cos is tan theta, so this is tan theta minus 1, and 1 by secant. Reciprocal of cos is 1 by reciprocal of cos is secant, and once again it's tan theta plus 1 plus secant theta. Okay, so we have got this converted into tan and secant, and between tan and secant there is an identity which says 1 plus tan squared theta is equal to secant squared theta, which gives me 1 is equal to secant squared theta minus tan squared theta. And I'm going to replace 1 here by secant squared theta minus tan squared theta. This is actually minus 1. So this is minus 1, negative 1, and this is negative. Okay, so we are not going to make any changes in the numerator, and I'm going to club tan theta and minus secant theta, and we have plus 1. So instead of 1, I'm going to write this. This is secant squared theta minus tan squared theta. Okay, so this is now tan theta minus 1 plus secant theta. And for this, I'm going to take negative out. So this is now secant theta minus tan theta plus, this is a square minus b square. So this is a minus b into a plus b. Okay, this is tan theta minus 1 plus secant theta, and this is secant theta minus tan theta. And if we take secant theta minus tan theta out of these two terms common, so this is now minus 1 plus its secant theta plus tan theta. So this is same. And finally, we have 1 upon secant theta minus tan theta, which is our RHS. So we have proved the identity. Now for question number 27, part A, it's given that coins are tossed simultaneously. What is the probability of getting at least one head? Okay. So for question number 27, 3 coins are tossed simultaneously. So the total outcomes for question number 27, part A, total outcomes is 2 cube 8. Now let's list all the outcomes. 8. So the total outcomes are 8. So this is 8 and half of 8 is 4. So I'm going to write 4 times head and 4 times tail. Okay, half of 4 is 2. So head 2 times head, 2 times tail, 2 times head, 2 times tail. Okay, half of 2 is 1. So 1 time head, 1 time tail, 1 time head, 1 time tail, head, tail, head, and tail. Okay, so this is the sample space of 8 outcomes. Let's move on to the first part, which says probability of at least one head. So probability of at least one head means it's the head means it's one or more than one. So head is greater than or equal to one. The number of head is greater than or equal to one. So greater than or equal to one are these are three, two. Greater than equal to one would be one, two, and three. So we have to consider all where the head is one times or two times or three times. So this one, two times, one time, two times, one time, and one time. So we have total of seven. So 7 by 8. Now this was our first. And second one, exactly two tails. So probability of exactly two tails means we have to count the outcomes where we have exactly two tails. So exactly two tails are here and here and here, exactly two tails. So these are 3 by 8. Out of 8, 3 in 3 outcomes, we have exactly two tails. So this is 3 by 8. And last one is probability of at most one tail. So probability of at most one tail means either the number of tails are 0 or 1. And the number of tails 0 are here, 1 is here, 1 is here. This is 2, 1. This is 2, 2, and 3. So 1, 2, 3, and 4. So this is 4 by 8, which is half. This solves our first part of question number 27. Moving on to the second part. For question number 27, part B, it's given that a box contains 90 discs which are numbered 1 to 90. So this is part B, and this is a probability based question. So total outcomes, because the discs are numbered 1 to 90, so total outcomes are 90. Now one disc is drawn at random. Find the probability that it bears a two-digit number less than 40. So probability of a two-digit number less than 40 is equal to total outcomes are 90, and two-digit number starts from 10 and less than 40 will be till 39. And if we count these numbers, so from 10 to 20, this is 30 and then 39. So this is 10 to 20 are 11 numbers, 20 to 30 are 10, and these are 9. So this is 11 plus 10 is 21, and 9, this is equal to 30. So there are total 30 numbers, two-digit numbers, which are less than 40. And so our answer here is 1 by 3 is the probability. Okay, for second part, the number divided by 5 and greater than 50. So greater than 50, number divided by 5 are 55, 60, 65, 70, 75, 80, and 85. And if we count these 1, 2, 3, 4, 5, 6, and 7, we have to go up to 90. So this is 8. 90 is also included. So this is 8. So probability of number divisible by 5 and greater than 90 are, so probability of number which is divisible by 5 and greater than 50 is equal to these total numbers are 1, 2, 3, 4, 5, 6, 7, 8. So 8 by 90. And 8 by 90 would give me 4 and 45. So this is 4 by 45 is the probability. Now the probability of a perfect square between 1 to 90. Now the perfect squares between 1 to 90 are 1 square 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square 25, 6 square is 36, 7 square is 49, and 8 square is 64, 9 square is 81. Okay, so these are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So probability of a perfect square, probability of a perfect square is equal to total of 9. So 9 by 90, which gives me 1 by 10. So this is 1 by 10. And moving on to next question, that is question number 29. And for question number 28, it's given that Rehana went to a bank to withdraw rupees 2000. He asked the cashier to give her rupees 50 and rupees 100 notes only. So the denominations are rupees 50 and 100 notes. And Rihanna got total of 25 notes. We have to find the number of 50 and the 100 notes she received. So this is question number 28. And let number of 50 rupee row notes be X and number of 100 rupee notes be Y. So according to this question, the total notes, that is the count of these notes, is 25. So this is our first set of equation. And if we have X number of 50 notes, so the money would be 50 into X. And if we have Y number of Y 100 notes, then the money is 100Y, and total money withdrawn was rupees 2000. So we can further reduce this equation. So this is 50 is common. So this is X plus 2Y is equal to 2000. And this is now 5 4s are is 20, 0. So this gives me X plus 2Y is equal to 40. This is equation 2. Okay, if we have to solve these equations, so I'm going to subtract these two equations. So x plus y is equal to 25 and x plus 2y is equal to 40. If I subtract these two equations, this gives me y minus 2y is negative y, 25 minus 40 is negative 15. So y is equal to 15. And if from equation 1, this equation gives us that x plus 15 is equal to 25. So that means x is equal to 25 minus 10, which gives me x is equal to, sorry, this is 25 minus 15. So this is 25 minus 15, which gives me 10. So number of 50 rupee notes. Now the number of 50 rupee notes, I can write in the end that the number of 50 rupee notes is equal to 10, and number of 100 rupee notes is equal to 15. So 10 plus 15 is 25. Okay, now moving on to question number 29. Okay, for question number 29, by part A, we have to find the zeros of the polynomial. So let's say this is part A, and let's say the polynomial is p of x is equal to 4x squared plus 4x minus 3. Okay, now here A is equal to 4, B is equal to 4, and C is equal to negative 3. So A into C is equal to 4 into negative 3 is equal to negative 12. Now we have to find the zeros. So factors of negative 12, that gives me the product negative 12, and the sum as 4 are 6 and 12. So the factors are 6 into minus 2 is equal to negative 12, and 6 added to negative 2 is 4, which is a middle term. So I'm going to use the factorization methods. 4x squared plus, instead of 4x, I'm going to write 6x minus 2x minus 3. Okay, and for these two terms, common is 2x, so x plus 3. And for these two terms, let's take negative 1 out. So this is uh, 4x squared plus 6 minus 2 is 4, 2x, and this is negative 3. Actually, this should be, if we take 2x common here, so this is 2x plus 3 and negative 1 common, which gives me 2x plus 3. And for these two terms, common is 2x plus 3. So we are left with 2x minus 1. So these are the factors. And the first factor is if we equate this to 0, which gives me x is equal to minus 3 by 2. And if we equate this to 0, which gives me x is equal to 1 by 2. So x is equal to 1 by 2 and x is equal to negative 3 by 2 are the two zeros. Now we have to find the relationship between, verify the relationship between the zeros and the coefficient of the polynomial. And the first relationship is that the sum of zeros is equal to negative b by a. And these are the zeros. So sum is minus 3 by 2 plus 1 by 2 negative b. B is 4 and a is 2. So this is 4 by 2 minus 3 plus 1 is negative 2 by 2, which gives me negative 1. So, and this is B. So B is 4 and A is also 4. So this is 4, which gives me negative 1. So negative 1 is equal to negative 1. So the first relationship is verified. The sum of zeros is equal to negative of the coefficient of x upon the coefficient of x squared. Next is the product of zeros is equal to c by a. Now the product of zeros is alpha into beta. So this is alpha into beta is equal to c by a. Let's put in the value of alpha and beta. So alpha is minus 3 by 2, beta is 1 by 2, and c is negative 3 and a is 4. So negative 3 and a is 4. So this is equal to negative 3 by 4 is equal to negative 3 by 4. So we have verified the relationship that the product of zeros is equal to uh, constant divided by the coefficient of x. Hence, the relationship is verified. Let's move on to part B of this same question. Okay, so part B of the same question, it says that alpha and beta are the zeros of the polynomial here. Okay, so part B says alpha and beta are the zeros of the polynomial. So the polynomial is x squared plus x minus 2. Here a is equal to 1, b is equal to 1, and c is equal to negative 2. So a into c is equal to 1 into negative 2 is equal to negative 2. And the factors of negative 2, that gives me product as negative 2 are 2 and negative 1. Because 2 into negative 1 is equal to negative 2 and 2 negative 1 is equal to 1, which is the middle term. So I'm going to write this middle term as the sum of 2x, that is the factors of negative 2. And for these two terms, common is x. So this is x plus 2. For these two terms, common is negative 1. So this is x plus 2. Again, x plus 2 is common. So this is x minus 1. So these are the two factors, and if we equate each of these factors to 0, this gives me x is equal to negative 2 and x is equal to 1. So these are the two factors. Let me say that this is alpha and this is beta. Now we have to find alpha upon beta plus, so this is alpha upon beta plus beta upon alpha. And here the LCM is alpha beta, so which gives me alpha square plus beta square. Now alpha square plus beta square, if we use identity a plus b the whole square, which gives me alpha plus beta the whole square minus 2 alpha beta upon alpha beta. So this we have got from the formula a plus b the whole square. So a plus b the whole square is a square plus b square plus 2ab. And we have to find alpha square plus beta square. So alpha square plus beta square is equal to, shift this to the left hand side. So alpha plus beta the whole square minus 2 alpha beta. Now alpha plus beta is negative 2 plus 1. So this is negative 2 plus 1 the whole square minus 2 alpha into beta is minus 2 into 1 upon minus 2 into 1. So minus 2 plus 1 is negative 1, square is 1. This is plus 4 upon negative 2. So this is negative 5 by 2. So negative 5 by 2 is the answer. Moving on to question number 30. For question number 30, we have to prove that 2 minus root 3 by 5 is an irrational number. Hence, given that root 3 is irrational. So this is question number 30, and let us assume that 2 minus root 3 by 5 is rational. So if 2 minus root 3 by 5 is rational, so that means 2 minus root 3 by 5 should be equal to a by b, where a and b are co-primes. That is, they are not divisible by any number except 1. So if this is 2 minus root 3 by 5 is equal to a by b, and if I rearrange this or cross multiply this, which gives me this is b into 2 minus root 3 is equal to 5a, and now 2 minus root 3 is equal to 5a by b, and root 3 is equal to 2 minus 5a by b. Now here this is LHS and this is RHS, and if according to our assumption LHS is equal to RHS, so that means if this is irrational, then this should also be irrational, but this is rational, so that means our assumption is wrong. So we can write that RHS is rational. So here this is RHS is rational, but LHS is irrational. So that means our assumption is wrong. So we can write in the end that therefore our assumption is wrong. Hence, the given number, that is 2 minus root 3 by 5, is irrational. Okay, moving on to question number 31. Okay, for question number 31, we have to prove that the parallelogram subscribing a circle is a rhombus. So for this, there is a parallelogram that is circumscribing a circle, and let this be the circle, and there is a parallelogram subscribing it. So this, okay, so let this be the parallelogram circumscribing a circle, and let me label this parallelogram as A, B, C, and D. And the point of contacts of the sides of this parallelogram with the circle B, P, Q, R, and S. So this be P, Q, R, and S. And if we look carefully at this picture, so D is the external point from where the two tangents are drawn. C is the external point from where these two tangents are drawn. B is the external point from where these two tangents are drawn. So these A, B, C, and D are now the external points where the two tangents are drawn. And we have to prove that this parallelogram is a rhombus. Okay, so we can write here that AP is equal to AS. So AP is equal to AS. And similarly, DS is equal to DR. And okay, instead of this, let me write AP with AP PB. So PB is equal to VQ and AP is equal to AS. So this is uh, next is DR. So let DR be equal to DS and RC be equal to CQ. So RC is equal to CQ and these the equations 1, 2, 3, and 4. And these are equal. Reason being the tangents drawn from an external point to a circle are equal. And what I'm going to do, I'm going to add these equations 1, 2, 3, and 4. And how do we add the equations? We add all these on the left hand side. That is AP plus PB plus DR plus RC. And the sides on the right hand side. So AH plus BQ plus DS plus CQ. Now AP plus PB. AP and PB if added gives me AB. So this is AB. And DR and RC. DR and RC when added gives DC. AS plus if I add AS to SD. So I'm going to add AS with DS. So AS plus DS. I'm going to club this and next is BQ plus CQ. So this is now AB plus CD and AS plus DS. So AS plus DS is AD. So this is AD and BQ plus CQ. BQ plus CQ gives BC. So this is BC. Now, but we know that ABCD is a parallelogram. So AB is equal to BC. Or AB is equal to CD. So AB is equal to CD and AD is equal to BC. So I can write that AD is equal to BC and reason being these are the opposite sides of a parallelogram are equal. Now AB is equal to CD means instead of CD I can write AB and so instead of CD I can write AB. Next is AD and BC are equal. So let me AB. Okay, so this is AD and BC is equal to AD. So instead of BC, I can write AD. So this is 2 times AB is equal to 2 times AD. So 2 and 2 gets cancelled. So that means AB is equal to AD. Now in this parallelogram, opposite sides are equal and also the adjacent sides are also equal. So this be, let's say this be the result 5 and 6. So we can write that from 5 and 6. AB is equal to BC is equal to CD is equal to DA. So in a parallelogram, if all sides are equal, in a parallelogram, all sides are equal. So that means, therefore, that means this parallelogram ABCD is a rhombus now. Okay, moving on to the next question. Okay, for section D, question number 32 is given that two pillars of equal lengths stand. So these are two pillars of equal lengths. They stand on either side of a road which is 100-meter wide, exactly opposite to each other at a point on the road between the pillars. The angles of elevation of the tops of the pillars are 60 and 30 degree. We have to find the length of each pillar and distance of the point on the road from the pillars. We have to use the value of root 3 as 1.732. So this is question number 32. And it's given that there are two pillars, equal pillars of equal heights, and distance between them is 100-meter. So this is the distance between them, which is 100-meter wide. And let this be pillar AB and this be pillar CD. Okay, now there is a point on the road between the pillars. So between this road, there is a point. It's not the midpoint, but there is some point anywhere on BD where the angles of elevation of the top of pillars are 60 degrees. So let this be the point. Let's say it's ED. And it's given that the angle of elevation of this point, the it's closer to this. So that means its angle of elevation should be greater. So this is 60 degree. And from here, the angle of elevation is, this is 30 degree. Okay. Now, let's say this is this distance between B and D is 100 meters. So I'm going to convert this in terms of BE. So I can write it that this ED as 100 minus B. So this ED distance is 100 minus B. Okay. And what we have to find out, we have to find out the height of the pillars, and we have to find the distance between them. That is, we have to find BE and we have to find ED as well. So I'm going to use tan in these triangles, ABCD. So the first one is in right angle triangle ABE. If I use tan 60, which gives me AB by B, and we know that tan 60 is root 3. So this is equal to AB by BE. And if I cross multiply this, which gives me AB is equal to root 3 into BE, and let this be equation 1. Similarly, I'm going to use tan ratio in the next triangle. So the first one was in right angle triangle ABE, and the second one is in right angle triangle EDC. Once again, I'm going to use here the ratio tan. So tan 30 is equal to perpendicular by base, and the value of tan 30 is root 1 by root 3, and 30 is 1 by root 3. Now CD and ED, I can, instead of ED, I can write 100 minus BE. And if I cross multiply this, which gives me CD is equal to 100 minus BE by root 3. So this is equation 2. And according to question, these pillars are of equal heights. That means AB is equal to CD. So if I substitute the value, so this is root 3 into BE is equal to 100 minus B upon root 3. And if I cross multiply this, this is 3 times B, because root 3 into root 3 is 3. So 3BE is equal to 100 minus B, which gives me 4BE is equal to 100. And this is 100. And BE is equal to 25 meters. Okay, so we have got the distance of BE. So this BE is 25 meter, and we have to find, so this is 25 meter, and we have to find ED as well. So ED is equal to 100 minus 25, which is equal to 75 meter. Also, we have to find the height of both the pillars and both the pillars being same in height. So I can write this is 100 minus BE by root 3. So BE is 25. 100 minus 25 is 75 root 3. And let me rationalize this. So this is 75 root 3. Root 3 into 3 is 3. And 3 to the 6, 5 are 15. So this is 45 into root 3, and it's given in the question we have to use the value of root 3. So root 3 was given, which is 1.732. So if I put in the value of root 3 here, so this is 1.732. So 25 into 1.732 should give me the height of the pillars, and 25 into 1.732 is 43.3. So this is 25 into 1.732, which gives me 43.3 meters. So this is 43.3 meter is the height of both the pillars. Okay, let's move on to question number 33. Okay, for next question, that is question number 33, part A. It's given that E is a side on E is a point on the side AD produced of a parallelogram ABCD and B intersects CD at F. Okay, so this is question number 33, part A, and it's given that ABCD is a parallelogram. So this is, so let this be the parallelogram ABCD, and it's given that E is a point on the side AD produced. So if I produce in, there is a point E and B intersects. So if I join BE, it intersects CD. So if I join BE, it intersects CD at F. So this is F. Now we have to show that triangle ABE is similar to triangle CFB. So this is the triangle ABE. So this is the triangle ABE, and we have to show that this triangle is similar to triangle CFB. So what is given to us is that ABCD is a parallelogram, and we have to show or prove that triangle ABE is similar to triangle CFB. Okay, so let's consider these two triangles for the proof. So in triangle ABE and triangle CFB. So if I consider these two triangles, first of all, in triangle ABE, angle A, and triangle CFB, this is triangle angle A and angle C are equal. So angle A is equal to angle C, reason being these are the opposite angles of a parallelogram, and we know that opposite angles of a parallelogram are equal. Now, this AB side is parallel to CD and BE is the transversal, so that means this angle and this angle are the alternate angles. So these are the sides, these two sides are parallel, and BE is the transversal, so that means angle AEB is equal to angle CBF. So angle AEB is equal to angle CBF. The reason being these are the alternate interior angles, and we know that the alternate interior angles are equal whenever the lines are parallel and there is a transversal. So we can write that by AA. So if two triangle angles in a triangle are equal, so that means the third It's obvious that the third angle is also equal. So by AA similarity rule, triangle ABE is similar to triangle CFB, and hence we have proved what was asked in the question. Moving on to the part B of the same question, that is question number 33, part B. Okay, for next question, that is, sorry, the same question. And part B, it's given that side AB, BC, and median AD of triangle ABC. So first of all, let's sketch these triangles ABC and DEF. So this is triangle ABC and this is triangle DEF. Okay, so ABC and triangle DEF. These are the triangles and there is a median AD. So median is a line segment drawn from the vertex of a triangle to the midpoint of the opposite side. So that means D is the midpoint, and another triangle is not DEF, it's PQR. Sorry for that. So this is PQR. And it has median PM, so median drawn from the vertex of a triangle to the midpoint of the opposite side. M is the midpoint. Okay, so let's write what is given to us. So it's given that side AB is proportional to PQ, is BC is proportional to QR, and AD is in proportion with PM. So AB is in proportion with PQ and BC. So this is side BC, which is in proportion with QR. AD is in proportion with median PM. And now we have to prove that triangle ABC is similar to triangle. Okay, so we have to prove that triangle ABC is similar to triangle PQR. Okay, and to prove this, let's consider what is given to us. So this is AB upon PQ is equal to BC upon QR is equal to AD by PM. Okay, this is given. Now, because D and M are the midpoints of sides BC and QR respectively, so that means if these two sides are in proportion, that means their half should also be in proportion. And now the half of BC. So half of BC, we can take BD, and half of QR, we can take QM. Okay, now these three sides are in proportion in the triangle ABD. Now AB by PQ and BD by QM and AD by PM, these are in triangle ABD and triangle PQM. So I can write that triangle ABD is similar to triangle PQ, and reason being we have used the by SSS similarity rule, which says that if the sides of the triangle are in proportion, then the triangles are similar. Now, then the triangles are similar, that means angle B should be equal to angle Q. So angle B is equal to angle Q. This is because these are the corresponding parts of the similar triangles. When the triangles are similar, then the corresponding parts of the angles are equal. Okay, now let's go back to triangle ABC and triangle PQR, in which AB by PQ is equal to BC by QR. This was given, and now angle B is equal to angle Q. So angle B is equal to angle Q, reason being we have proved this above. So now AB by PQ is equal to BC by QR, and this is the included angle, so that means by SAS. Similarity rule. Triangle ABC similar to triangle PQR. Okay, and let's move on to question number 34. Okay, for question number 34, part A, it's given that train travels the distance of 90 kilometer at a constant speed. So this is part A. And let me just write down the speed of train in kilometer per hour. So let the speed of train be x kilometer per hour. And the distance is 90. So distance is 90 kilometers. So when the speed is x kilometer per hour, time is equal to distance by speed, which is 90 by x in an hour. Now again, it's given that if the speed had been 15 kilometer per hour more. So if the speed increases, time decreases. So new speed is x plus 15 kilometer per hour. Distance, there is no change in distance. Distance is still 90 kilometer per hour. And now the new time. Now new time is again distance by speed. Okay. Now it's given that it's in hour. It's given that it had taken 30 minutes less for the journey. So that means the difference between this time and the this time is 30 minutes. So which time is greater? This time is greater than the new time because for the new time we have increased the speed. So more is the speed, less is the time. So according to question, I can write that the difference between these two times, that is 90 upon x minus 90 upon x plus 15 is equal to 30 minutes. And if I convert this to hours, so this will be 30 by 60, which will be 1 by 2. Okay, let's take 90 common. So this is 1 upon x minus 1 upon x plus 15, which is 1 by 2. And let's take LCM. So this is x into x plus 15. We are going to solve this using the quadratic equation. And this is 1 by 2 into 1 by 90. And this is now 15 upon x squared plus 15x is equal to 1 upon 1 by 80. So x squared plus 15x minus 15 into 80. So 15 into 18 gives me 270. So this is 2700 is equal to 0. Now this is the quadratic equation and we are going to solve this quadratic equation. Okay, to solve this quadratic equation, let's use the factorization method. And here A is 1, B is equal to 15, and C is equal to negative 2700. So if I multiply A into C, which gives me 1 into negative 2700, which is negative 2700. So that means I have to find the factors of 2700 such that their product is negative 2700 and sum is 15. So this goes by 3, 900, 300, and then 250, 225, 5525. Okay, let me find out the factors for this. And the factors are 5 to the 10, 3 to the 6. So this gives me 60 and 3 into 5 is 15. So 60 and 15. 60, sorry, it's 60 and 3 to the is 6. 6 to the is 5 to the 10 and 60. This will be 903. Actually, this should be, this is actually 300. And then it's 100. So this is 250, 225, and 5 and 5. So 3 to the is 6. and 5 twos are is 10. 10 into 6 is 60. 3 threes are 9, and 9 into 5 is 45. So 60 and 45. So it's 60 into negative 45. So 60 into negative 45 gives me negative 6 5 are 36, 4 are 24, 2700, and 60 minus 45 gives me 15, which is the middle term. Okay, so I have the factors x squared plus 60x minus 45x minus 2700 is equal to 0. For these two terms, common is x. So x plus 60, and for these two terms, common is negative 45. So x plus 60 is equal to 0. And x plus 60 into x minus 45 are the two factors. So x plus 60 is equal to 0 and x minus 45 is equal to 0. It gives me x is equal to negative 60, which is not possible. Speed cannot be negative. X is equal to 45. So the ordinal speed of the train is equal to 45 kilometer per hour. So let's see what was asked in the question. So we have to find the ordinal speed of the train, which is 45 kilometer per hour. And moving on to the part B of the same question. Okay, for part B, we have to find the value of C for which the quadratic equation has real and equal roots. So let me just write down the quadratic equation. So this quadratic equation is C plus 1 x square minus 6 into C plus 1 into x plus 3 into C plus 9 is equal to 0. Okay, here A is the coefficient of x square, which is C plus 1. B is the coefficient of x, which is minus C into C plus 1. And C is equal to, okay, now for real and equal roots, we know that D is equal to 0. Now D is equal to B square minus 4AC. So let's put the value of B, which is minus 6, C plus 1, the whole square minus 4 into A, which is C plus 1 into C, which is 3 into C plus 9 is equal to 0. Okay, minus 6 square is 36. So C plus 1 the whole square minus 4 into C plus 1 into 3 into C plus 9 is equal to 0. Okay, for these two terms, common is C plus 1. So I'm going to take that out. So this is C plus 1, and I'm left with 36. C plus 1 minus 4 into 3 into C plus 9 is equal to 0. Okay, so let's try to solve this. This is 36C plus 36 minus 12C minus 12 into 9. 9 to that is 18 and 108. It's equal to 0. So this is 36C plus 36 minus 12C minus 108. And C plus 1 into this is 36 minus 12 is 24C plus 108 minus 36 is 8 minus 6 is 2, and 10 minus 3 is equal to 0. So either C plus 1 is equal to 0, or 24 by C minus 72 is equal to 0. So this gives me C is equal to negative 1. From here, we can get that C is equal to 72 by 24. So 24 3 are is 72, so C is equal to 3. So these are the two values, and according to the question, the C cannot be negative 1. So C cannot be negative 1, so that means we have to ignore this, and the value of C is 3. So value of C is 3. And moving on to the next question, that is question number Okay, for question number 35, to find the mode and median for the information given in the tabular form. And let's calculate mean first. So I'm going to redraw this table once again. It's given the age in years and the number of patients FI. So age is 5 to 15, 15 to 25, 25 to 35. These are the class intervals 35 to 45 and 45 to 55 and 55 to 65. Okay, so the given frequencies are 6, 11, 21, 23, 14, and 5. Okay, so this is 5. Okay, so this is the information given, and let's find out the class marks, and we know how to find the class marks. So class marks are upper plus lower limit divided by 2. So upper plus lower limit divided by 2 of the class marks of the class intervals will give us the class marks. And we denote the class marks by xi. So this is lower plus upper. 5 plus 15 is 20 divided by 2 is 10. 15 plus 25 is 40 divided by 2 is 20. So this should be in the pattern 10, 20, and then 30, 40, 50, 60. So 20, 20, 30, 40, 50, and 60. And I'm going to find the product of the frequency with the respective class marks. So this is 60. 11 into 20 is 220. So this is 220. And this is 630. This is 4 threes are is 12, 4 twos are 8, 9, and 5 fours are 20, and 700. This is 300. So we have the product 60, 220, 630, 920, 700, and 300. And let's get the summation of this, the summation of Fi into Xi. So if I multiply this, this is 0, and 2, 3 plus 2, 5 plus 2 is 7, and 6 is 13, 1 is carried, 2, 3, 6, 9, and 9 is 18, plus 7 is 25, and 3 is 28. So this is 2830. And let's do the summation here for the frequency. So 6 plus 11 is 16, 6, 7, 8, 3, 11, 4 is 15, plus 5 is 20, 2, 2, 4, 5, 6, 7, 8. So this is 80. So this is sigma Fi, which is 80. Now let's calculate the mean by the direct formula, which says that is the summation of sigma Fi into Xi divided by sigma Fi. So this is 2830 divided by 80. This gets cancelled, and it's 8. 3s are is 24, and 43. So 8 5s are is 43, and 8 3s are is 24 once again. So 35.375 should be the mean. Okay, now we have to find mode, and for mode, so we are done with the mean. Let's find mode, and for mode, our model class is the one with the highest frequency, which is 35 to 45. Its frequency is the highest, 23. So let me just write down the class, which is 25, sorry, 35 to 45. So 35 to 45 is the model class. So now let's write down the formula for the mode, which is L plus This is f1 minus f2 upon 2f1 minus f1 minus f2 into h. So let's put in the respective values. L is the lower limit of the model class, which is y plus f1 is the frequency of the model class, which is 23, and f2 is the frequency of the model class succeeding. F1 is the frequency of the class interval succeeding the model class, which is 14. So this is 23 minus, okay, so this is actually 1 minus f naught. 2f1 minus, so this is f naught is the frequency of the class succeeding the model class, which is 21. So this minus 21 upon 2 into f1. F1 is the frequency of the model class, which is 23 minus, and it's f naught, which is 21 minus f2. So this is f2, this is f1, and this is f naught. Let's put in the respective values in the formula. So f2 is 14. So this is 14, and h is the class size, which is the upper limit minus lower limit of any of the class intervals, which is 10. Okay, if we simplify this, this is 35 plus 23 minus 21 is 2. 2 into 23 is 46, minus this should be 5, 35 into 10. So this is 35 plus 2 upon, this is 11 into 10. Okay, now 35 plus, this is 2 divided by 11. This should be point, 11 ones are is 11, and okay, so we have to divide 2 by 11. So this is point 11 ones are is 11, 98, and 88 and 20. So I can write it as 0.18 into 10, which gives me 35 plus, if you multiply this with 10, this is 1.8. So this is actually 36.8. So 36.8, or is 818, or in two decimal places I can write it as 36.81. So 36.81 is the mode. Okay, let's move on to the next question, which is question number 36. Okay, for question, which is of section E, and this section has 3 case study based questions of 4 marks each, and the first one is, for Real from a very young age was fascinated by the twinkling of stars and the vastness of space, and he always dreamt of becoming an astronaut. On one day, so he started to sketch his own rocket designs on the glass sheet and even below. So this is a rocket design. And regarding this, we have to answer the questions. We have to find the midpoint of the segment FG. So FG segment, this is the coordinate. This is the point F, and its coordinates are minus 3, comma 0, so it is on the x-axis, and G, the coordinates of G are 1, comma 4. So we have to find the midpoint of this line segment FG, and I know that the midpoint is given by the formula. So these are the coordinates of midpoint, which is given by the formula x1 plus x2 by 2, comma y1 plus y2 by 2. This should be the x and this should be the y coordinate, and the values of x1, y1, and x2, y2. These are the two coordinates. So x1 is minus 3 plus x2 is 1 divided by 2. Y1 is 0, y2 is 4 divided by 2, which gives me minus 2 by 2 is minus 1, 2. So minus 1 and 2, minus 1, comma 2. So this is minus 1 comma 2. This is the midpoint of the line segment FG. Okay, moving on to the next question, which is on the next page. So what is the distance between the points A and C? So we have to find the distance between the points A and C. So this is point A. So this A should has its coordinates are 3 comma 4. It's 3 and 4. So coordinates are 3 comma 4, and coordinates of C, it's -1 comma -2, and we have to find the distance AC. So to find distance AC, let's use the distance formula, which says it's x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, x2. So 3 is x2, so 3 minus of minus 1 the whole square plus y2 is 4 minus of minus 2 the whole square. So this is 3 minus of minus 1 is 4, 4 squared is 16, plus 4 minus of minus 2 is 6 square is 36. So this is under root 6, 6, 12, 3, 4, and 5, 52. So 52 can be written as 2 into 2 into 13, which is equal to 2 under root 13 units. So 2 under root 13 units is the distance AC. Okay, moving on. The next part, okay, for OR, the same question, we'll find the coordinates of the point which divides a line segment joining the point A and B in the ratio 1 is to 3. So A and B in the ratio 1 is to 3. We have to find the, so A and B. Let's get the coordinates of A and B. Okay. So the coordinate of A is 3 comma 4. So this is 3 comma 4, and B has the coordinate 3 comma 2, and this has to divide the system on, let's say P in the ratio 3 is to 1. In the ratio, sorry, 1 is to find the coordinates of point P, and for that we are going to use the section formula. So if I use the section formula, which says the coordinates of the point that divides a line segment in the ratio M1, so this is M1 is to M2. So M1 is to M2 is equal to 1, 3, and these are our coordinates x1, y1, and x2, y2. So using the section formula, it should give us the coordinate of the point P, xy, and the formula says M1 into x2 plus M2 into x1 divided by M1 plus M2, M1 plus M2, and y coordinate is M1, y2 plus M3 y1 upon M1 plus M2. Okay, so x comma y is equal to M1. M1 is 1 and x2 is 3, M2 is 3, and x1 is, sorry, x1 is 3. X1 is 3. And M1 plus M2 is 1 plus 3. Okay, once again, 1 into y2 is 2 plus 1. Sorry, M2 is 3 into y1, which is 2 divided by 1 plus 3. This is 3 plus 9 divided by 4, and it is 2 plus 12 divided by 4 is equal to 12 divided by 4. 2 plus 12 is 14 divided by 4. This is 3. So the coordinates are 3, and this is 7 by 2. So 7 by 2, 3 comma 7 by 2 are the coordinates of the point P, which divides AB in the ratio 1 is to 3. Okay, moving on to the next part. What are the coordinates of the point D? So coordinates of the point D, and draw the perpendiculars to the x and the y axis from the D. It should give me the coordinates. The coordinates are -2 comma -5. So D has the coordinates -2, comma -5. Moving on to the next question. That is question number 37, case study 2. Okay, for case study 2, question number 37, it's given that there is a treasure hunt game, which is an exciting and an adventurous game where participants follow a series of clues and numbers or maps to discover hidden treasures. And they engage themselves in a thrilling quest, solving puzzles and riddles to unveil the location of the coveted prize. So, while playing one such game, some clues are hidden in the various spots and they are forming an AP. And the number on the end spot is 20 plus 4. And so that means there are some spots, and on these spots there are some numbers which are clues. And to get these numbers forms an AP. So these numbers forms an AP. So this is an AP with some numbers at the clues, and if you have to get a particular number, that is then that spot, so this spot or any other spot is given by uh, the equation 20 plus 4. And so that means these are the terms, and nth term is given by the formula 20 plus 4. And so this is the formula to get any of the spots. You just put, this is the first spot, this is the second, this is the fourth, fifth, sixth, and if you put 1 in this, it will give you the number on the first spot. And if you put 2, it will give you the number on the second spot. So which number is on the first spot? So for first spot means n is equal to 1. So if we put n is equal to 1 here, which will give us the number on the first spot. So a1 is equal to 20 plus 4 into 1, which is equal to 24. So the number on the first spot is 24. And the next question is, which spot is numbered as 112? So there is a certain number of the spot which is 112. So that is, let's say that the n spot is 112, and we know that n spot is given by a plus n minus 1 into d is equal to 110. We know the value of a, which is 24, but we don't know the value of d. So value of d, to find the value of d, let's calculate or find out the second term. So this is 20 from this equation, 20 plus 4 into t, which gives me 28. So the second term is 28, first term is 24, and d is, if we calculate d, this is 28 minus 24, which is 4. So d is 4. So this is 24 plus n minus 1 into 4 is equal to 112. So n minus 1 into 4 is equal to 112 minus 24, which gives me n minus 1 into 4. 12 minus 4 is 8. 10 minus 2 is 8. And n minus 1 is equal to 22. N is equal to 23. So that means 23rd spot has the term 112. Now, what is the sum of all the numbers on the first 10 spots? So we are asked to find the sum of first 10 numbers on the spot, which is given by the formula S of n. This is part B. S of n is equal to n by 2 into 2a plus n minus 1 into d. Now we have to find numbers on the first 10 spots. So n is equal to 10. So S of 10 is equal to n is 10 by 2, 2 into a. A is 24 plus n minus 1. 10 minus 1 is 9, and d is 4, which gives me 5. 2 into 24 is 48 plus 36. So 5 into 48 plus 36 should give me the sum of the first 10 numbers on the spot. So 48 into 36, 8, 6, 14, 47, and 8. 5 fours are is 20, 8 fives are 40, and 42. 420 is the sum of the numbers on the first 20 spots. Which number is on the n minus 2 spot? So this is part B. We have to find which number, that is the term on n minus 2 spot. And we know that nth term is given by, if we have to find the nth term, so here the formula for nth term was given by which was given by 20 plus 4n. So this was 20 plus 4n. Now instead of n, we have to write down n minus 2. So we are going to replace n as n minus 2. So this is n minus 2 term. This is 20 plus 4 into n minus 2. So this is equal to 20 plus 4n minus 8. And this is 4n 20 minus 8 is 12. So that means n minus 2 spot or the term is 4n plus 12. Okay, let's move on to the final question of this paper. Okay, for case study 3, this is the final question of this series, and it says that tamper-proof Tetra Pak milk guarantees both freshness and security. This milk ensures uncompromised quality, preserving the nutritional values within it, making it a reliable choice for health-conscious individuals. And this is the milk packet. This is packed in these cartons. So this is the carton in which this milk packet is packed. This is the milk packet, and this is the glass in which it can be poured. So 500 milliliter of milk is packed in a cuboidal. This is cuboidal container of dimensions 15 by 8 by 5 centimeters. So that means it's 15 centimeter in length. So the length, so this could be 15 and this could be 8 and this could be 5 centimeter. So length, breadth and height of this milk packet is given. These packets are then packed in cuboidal cartons. So these are cuboidal cartons of dimensions length, breadth and height of this is also given. So this could be 32 the centimeter and this is let's say 30 and this is breadth is 50 of this carton. So these are actually the length, breadth and height and the length, breadth and height of the milk packets in the cartons. So find the volume of the cuboidal carton. So this is the cuboidal carton and the volume of the cuboidal carton is given by length into breadth into height. We have to find the volume. And if we put in the length, breadth, and height of the cuboidal carton, these are 30. So this is 30 into 32 into 15 centimeter cube. And 30 into 32 is 960 into 15 and 960 into 15. So if we multiply 960 into 15, this is equal to 14,400 centimeter cube. So 14,400 centimeter cube is the volume of the cuboidal carton. Okay, find the total surface area of the milk packet. So this is cuboidal, and the total surface area of the milk packet. This question number 2 is this is the total surface area of the milk packet, which is given by the formula 2 into LB plus BH plus LH. And if you put in the respective values, so these are the dimensions of the milk packet. So 15, L into B is 15 into 8 plus B into H is 8 into 5 plus L into H. So length into height is 5. So this is equal to 2 and 15, 8 is 8 5s are 40, 120 plus 40 plus 75. So this is equal to 2 into 140 plus 20 is 160 plus 75. Okay, so 15 into 8 plus 8 into 5 plus 15 into 5. So this is 2 into 5, 7, 6 is 13, 2, which gives me 5 to that is 10, 2, 3 is 6, 7 to the 4 and 5. So 2 to the 4, sorry. So this is 5 to that is 10, 2, 3 is 6, 7 and 4. So this is 470 centimeters square because it's the area. Now, how many milk packets can be filled in a carton? So part B, number of milk packets that can be filled in a carton. So that should be the volume of a carton divided by the volume of one milk packet. And the volume of the carton will be length into breadth into height, which is 30. So this is length, volume of carton is length into breadth into height. These are in centimeter. And for uh, milk packet, it's 15 into 8 into 5 volume, length into breadth into 5. So 15 into 8 into 5. So 15 into 15, 15, 8, 4s are, and 5, 6 that is 30. So which gives me 24 packets. Now, uh, for the third one, it says that how much milk can the cup hold? So this cup is in the cylindrical form. So volume of milk in cup would be the volume of the cylinder. So volume of milk in cup that is equal to pi r squared. So pi is 22, the radius is 5, so its square is 25, height is 7. 7 gets cancelled, so 22 into 5. So 22 into 5, it's 550 centimeter cube. And because the quantity is small, so we know that 1 centimeter cube is equal to 1 milliliter. So I can also write it as 550 milliliter of milk this cup can hold. Okay, so with this, we are done with this question paper. Do like, share, and subscribe. Thank you for watching.